Hi everyone, welcome back to our math channel online today. Today I will upload a few videos for the last chapter of Pre-Calculus Math 12. This is the last chapter, Trigonometric function. And if you register to our math course online, you can have a chance to have an access on the written document, some sample solution, as well as practice exercise and practice final exam. And if you want to earn a certificate of recognition, then you will have to register for the final exam. Other than that, you can treat our online course as your assistant teacher or academic tutor one-on-one. You can rewind, rewatch, and try to understand those steps. As I mentioned, math only have one universal language. Doesn't matter you learn with what teacher, what school, in Canada or in USA. Logarithmic function is logarithmic function. Trigonometric function is trigonometric function. So as long as you absorb the concept, doesn't matter what question in the exam gave to you, as long as you understand, you know how to do it, you can pass any exam test in your school. So I hope that all students across the world will be able to join our online school. I might be busy in the next September. I will not be able to post a lot of lesson plan online or whatever if I'm very busy teaching full time. But if I have a chance, I still try to create the course online and provide you the best high qualified video teaching and lesson plans for our online school. But it will take time, so I hope that everyone will support our online school by visiting our website, mymathteaching.ca, and register to our online courses. So thank you for watching, and let me get into the question today right away. Today I will show you how to simplify the trigonometric function expression before we get into proving trigonometric identity. So on the board, I have one question. Secant square theta minus tan square theta divided by sine square theta plus cos square theta. And we want to reduce this expression to a seamless form as much as we can. So let me show you how to do that. Now, before we simplify, I want to mention there is some trigonometric identity, right? Trig identity, which is very useful for us to simplify this expression. And the first one is sine square theta adding with cos square theta always equal 1. I can draw this expression, but I don't think it's necessary because we're going to draw a lot anyway, right? So these are very simple trigonometric identity. Once we be able to simplify it, we can draw it as well. So these are the basic one. We pay attention so that we can use it to simplify. So you will have a secant square theta equal 1 plus tan square theta. That is the second identity. And you also have a cosecant square theta equal 1 adding with cos square theta. So using these three basic information, we'll be able to simplify any expression. So let's simplify this. Now, you also know that secant square theta is the inverse trigonometric of cos square theta. So I'm going to change the secant square theta equal Actually, I can use this one right here, right? Secant square theta equal 1 plus tan square theta. So let's do that. Secant square theta equal 1, adding with tan square theta. And now minus tan square theta, we copy it down, right? Down here, we have sine square theta plus cos square theta. And sine square theta plus cos square theta, we use the first one, which is equal 1. So now we can cancel the tan square theta with tan square theta minus, right? And this expression just equal 1. So how simple it is, okay? Now, let's do the next question. Secant theta, tan theta divided by cosecant theta, tan theta, secant theta minus 1. So this look a little bit more complicated, right? So now let's see which approach we should do it. Okay, so what I'm going to do, I am going to change the top, right? Change the top, become, I'm going to change the top, become 1 over cos theta, secant theta is 1 over cos theta, time with sine theta over cos theta, because tan theta is equal sine theta over cos theta. So that is the top. Now I'm going to do with the expression at the bottom. So for the expression at the bottom, I'm going to turn this into 1 over sine theta, because cosecant theta is 1 over sine theta. Tan theta means sine theta over cos theta. And secant theta is 1 over cos theta. So this one turn into this, and this, minus 1. So now on the top, I'm going to simplify the top here, and the top become sine theta, 1 times sine theta, cos theta times cos theta is cos square theta. At the bottom, I'm going to cancel the bottom here, right? You see I can cancel the sine theta here with the sine theta here. And I have to combine this and this, become 1 over cos square theta, right? Cos theta times cos theta, cos square theta, minus 1. Now, at this point, I'm going to leave the top is the way it is, sine theta over cos square theta. But I have to do common denominator for the bottom, right? This is the 2 fraction, right? A whole number, the fraction subtract the whole number. So I'm going to put 1 underneath, and it means I can keep this numerator here as 1. But for this one, I have to time with cos square theta to make the common denominator, right? As well as down here, I have to tie the same cos square theta. So that becomes 1 minus cos square theta. All of them will be underneath the same denominator, which is cos square theta. So at this point, I look at the first fraction on top, divide by the second fraction at the bottom. Now I'm going to do shortcut. We can use the first fraction, multiply with second fraction upside down as well. We can do that as well. But I like to do shortcut because I know it's correct. So I'm going to just cancel the cos square theta denominator of the first fraction up here and denominator of second down here. So I left with sine theta on the top. And down here, I have 1 minus cos square theta. Now 1 minus cos square theta, if I transfer this equation, if I move this over here, I will have 1 minus cos square theta equals sine square theta. So this whole thing here, this one here will be equal to this, sine square theta. And now I can cancel the sine theta on top and put the 1 here. And down here, I can cancel the square. I left with sine theta. And this is the farthest I can go for the second simplification. So that's how you do it. Now let's do number 3. I'm going to choose the complicated equation to simplify for you to see, right? So I will have tan theta cosecant square theta minus tan theta cos square theta. All of this will be over sine square theta time with secant theta time with cosecant theta and cot theta. So let's see how we're going to simplify this complicated expression. Now, what I noticed that on the top here, I can take the common denominator out. We have tan theta as a common denominator. So let me do that first. So this will be equal to the top. I will take out the tan theta as a common denominator. Inside, I have cosecant theta minus cos square theta. And underneath here, I'm going to turn this into 1 over, now actually it's okay because that is sine square theta. So just leave it. The secant, I'm going to change it into 1 over cos theta. Time with cosecant, I'm going to change into 1 over sine theta. And cot theta, I'm going to change it into, now the tan equals sine over cos. So the cot will be opposite, right? Because cot is the inverse of the tan. So instead of sine over cos, will be cos over sine. So it will be cos theta over sine theta for cot theta. For this one right there, right? So now let's see what we can cancel. Now I'm going to take advantage, the top, I'm going to take advantage of this expression here. Cosecant square theta equals 1 plus cos square theta. So I'm going to turn that into that. So I change this, become 1 plus cos square theta. And I still have the cos square theta here, right? Minus cos square theta here. Now at the bottom, I can cancel, right? The denominator here, the bottom here. I can cancel sine square theta with the sine theta here, which is power 1, and another one, which is power 2. So we can cancel this, all of this. Now the cos theta also at the bottom is on top. We can cancel bottom and top as well. So we leave us with everything done. We leave with 1 only, right? So now we know that inside the bracket we have cos square theta plus and this is minus. So that also gone. And 10 times theta times 1 is just 10 theta. So here you go. It's very clean cut, right? from here, expression, complicated expression now become only tan theta, which is very nice. So I like to play around with this stuff actually. So let's give you one more exam, one more sample. And then the next video, maybe we can, it will be good to go for proving trigonometric identity. So the next example I want to give you is number 4, which is sine square theta minus sine theta cos theta and minus 2 cos square theta all of this over sine theta plus cos theta. Okay, now this is look like a quadratic function. I notice it, right? So let me say, I can rewrite it in terms of quadratic function, or I can just use it. But let's say I say let A equal sine theta and let B equal cos theta. Let's say to make like that so it look easier for you, right? So I will have the top, I will change this become A square minus A times B, this is A, this is B, minus B square, right? So that's the top. Now the bottom is still the same, sine theta plus cos theta. And actually this is 2. So if I break this one, become 1 times 1, and I break this 1, become 2 times 1. I will put in the side word here will be 1 times 1 and 2 times 1. I do cross multiply, 1 times 1 is 1, 1 times 2 is 2. Now, if I subtract this and this, I should get back to minus 1 right here, the midterm. So 2 minus 1, not going to give me minus 1. I have to assign correct side, this is minus 2 and plus 1. So when I add them, I will get minus 1 like that. So now it's correct. I'm going to circle the 2 circles. I'm going to factor them, become 2 brackets like this, right? So the top. Now the bottom still sine theta plus cos theta, right? Now the bottom, the first number will be my sine theta or A, right? If I let factor like this is like A. And when pick up the side here minus 2. And this will might be and plus 1. So if I multiply back, I got, sorry, this should be A and this should be B. So let's check. I will have A square plus AB and minus 2AB will give me minus AB. And the last term will give me 2B. So no, this have to be a B. What I'm doing, so A minus B. So A square plus AB. And this should be, no, this should be 2B, sorry. A square, right? Plus AB minus 2AB, so it become minus AB and minus 2B square, that's right. Over sine theta plus cos theta. So now I'm going to change it back. A square is sine square theta. So I say A equals sine theta minus AB. Now, this is just proving for you, right? This is proven that we factored right. So let's follow the factor. So A is sine theta minus 2b is cos theta times with a is sin theta plus b is cos theta. And down here we have sin theta plus cos theta. So look at this bracket and this bracket, we can cancel them. And our answer is just this one, sin theta minus 2 cos theta. So that's how you perform when you see something like this. So I hope this video is clear to you. And this is just like give you tools, but you have to practice on your own, right? And by watching it and know the pattern a little bit. When I was in high school, to be honest with you, my high school teacher didn't tell us how he proved it, how he simplified it. He just showed very quickly on the board, and we have to look at and try ourselves very hard. Now I provide you the pattern as well for you to see how we can break it down in what kind of pattern, right? But still, you still need the practice. So it makes it a little bit easier for you if you want, but still you have to practice on your own to get good at it. So I will end the video here and I will continue with the next video, which is about the proving trigonometric identity. Thank you for watching and bye for now.